All right, let's talk about Amazon DynamoDB. It's a NoSQL database, and it's really built for one thing and one thing only: insane speed, especially at scale. You know that feeling, right? When your app starts getting popular and then it just grinds to a halt? That's usually the database crying for help. Well, if you've been there, then this one's definitely for you.
It's kind of a good problem to have, but it's still a huge problem, right? Your app is a hit, it's scaling up, traffic is spiking, but your good old trusty relational database, it's just not having it. It starts to groan, things slow down, and you better believe your users are noticing. So what do? How do you get that speed and handle all that scale?
And that right there is the big promise of DynamoDB. We're talking consistent single-digit millisecond performance no matter how big you get. It's fully managed, it's serverless. Basically, it's designed to be crazy fast all the time, no matter how much data you're throwing at it. But, how does it actually do that? What's the magic? Well, to get that, we've got to break down its core components.
Okay, Section 1, DynamoDB's core components. Before we go any further, we gotta learn the language. The vocabulary is a little different from what you might be used to in the SQL world, but don't worry, the concepts themselves are pretty straightforward.
So everything starts with what's called a table. And honestly, the best way to think about it is just a bucket. That's it. It's the big container where you're going to dump all your application's data. All your user info, your product catalogs, games, stats, whatever. It all lives inside a table. All right, so inside that bucket, our table, we have what are called items. An item is just a single piece of data. If you're coming from a SQL world, this is super easy. An item is just a row or a record. It's one thing, One user, one specific product, that kind of thing. And then each of those items is made up of attributes. These are just the little data points inside the item. The user's name, their email, when they last logged in. But here's the big twist, and this is really a core NoSQL idea. The schema is totally flexible. One user item might have, say, a followers count attribute, but another user item might not. You're not stuck with this rigid one-size-fits-all column structure for every single record. It's a game changer. Okay, Section 2, the power of the key. So we've got the basics down: tables, items, attributes. Now, let's get to the most important concept in all of DynamoDB. I'm not kidding. This is the secret sauce. This is what makes it so mind-blowingly fast. We're talking about the primary key.
This right here, this is the number one non-negotiable rule. Every single item that you put into a DynamoDB table has to have a unique primary key. Just think of it like a street address for your data. It's not a suggestion, it's a requirement. It's how DynamoDB knows exactly where to go to grab your data instantly, without having to search around for it.
Now, this primary key can have one part or sometimes two. The first part, the partition key, you absolutely have to have it. Its whole job is to tell DynamoDB which physical server or partition to store your data on. That's the key to the speed, right there. Then there's the second part, the sort key, and this one's optional. It lets you organize a bunch of items that all have the same partition key. And trust me, this is going to be super important for modeling those one-to-many relationships. We'll get to that in just a bit.
Section 3, rethinking your queries. Okay, so understanding this whole primary key thing is so important because it completely flips how you think about getting your data. I mean, especially if you're coming from the SQL world where you can kind of just ask for anything you want, anytime you want.
Yeah, this quote really says it all, doesn't it? If your service requires ad hoc query access, then DynamoDB is probably not for you. Look, DynamoDB is just not built for making up complex queries on the fly, joining a bunch of tables, filtering by whatever you feel like. It's all about a fundamental trade-off. You give up that ask anything flexibility, and in return, you get absolutely blistering, predictable speed for the questions you planned to ask. And this really breaks down the two ways you can get your data out. On the left, you've got a scan, and it's as bad as it sounds. It literally reads every single item in your entire table, one by one, looking for your stuff. It's the brute force method. And yeah, it works, but it is slow and can get super expensive because you pay for every read. Now on the right, you have a query. This is the smart way. A query uses that primary key to go directly to your data. It's like a surgical strike. It's fast, it's efficient, it's cheap. Your goal, always, is to be doing queries. Avoid scans like the plague. So this brings us to what I call the golden rule of DynamoDB, and you have to burn this into your brain. With a normal database, right, you design your schema, your tables, and then you write your queries.
With DynamoDB, you have to flip that completely on its head. You have to know your access patterns, basically the questions you need to ask the database, before you even start modeling your data. The entire design is all about serving those specific questions as fast as humanly possible.
All right, Section 4, Data Modeling in Action. Look, I know that's a lot of theory, so let's make this way more concrete. We're going to walk through a real-world example. Let's model a player's profile in a video game and see how this query-first thinking actually plays out. Okay, so let's start with just one item. We'll say the partition key is the player's unique ID, account 1234, and for the sort key, we'll just use the word profile. This item is going to hold their basic stuff, password hash, last login time. Pretty simple so far.
But what about their stuff? Like their inventory? Let's add their armor. So we create a whole new item. But here's the crucial part. Look closely. It uses the exact same partition key, account 1234, but the sort key is different. We'll call it inventory armor. You see what's happening? We're starting to group related data together, all under that one account ID.
And we'll do the exact same thing for their weapons. Same partition key, account-1234, but a new sort key, inventory-weapons. What we've built here is what's called an item collection. It's just a fancy name for a group of items that all share the same partition key. And because they're physically stored right next to each other, we can grab all of them at once in a single, super fast operation. This is how you do one-to-many relationships in DynamoDB. And now, here's the payoff. This is why we did all that work. Because we were smart and we used that inventory prefix in our sort keys, we can run an incredibly powerful and efficient query. We can just say, hey, DynamoDB, give me everything for partition key account 1234, where the sort key starts with inventory, and boom, it instantly grabs the armor and the weapons, but it's smart enough to leave the profile item alone. We knew the question we needed to ask, we designed the data to answer it, and we got the speed we wanted.
Okay, Section 5, the big picture. Let's zoom out for a second and just recap why you would even choose DynamoDB in the first place. What makes it so powerful for the right kind of job?
So let's just run through the highlights. First, it's serverless. That means you're not managing servers, you're not patching anything. AWS takes care of all that grunt work. Second, you pay per request, which is amazing for workloads that are all over the place. The flexible schema means you're not trapped when your app needs to change. And of course, the big one, that consistent, reliable, single-digit millisecond performance, that means you can scale to the moon without your database becoming the bottleneck.
But really, at the end of the day, the biggest takeaway isn't just a list of features. It's about a completely different way of thinking about your data. So let me just leave you with this question to chew on. For your next project, what if you started by defining the exact questions, the exact queries that your application needs to be fast? How would that change how you build it right from the very beginning? That's what it means to design for speed at scale.